Right, hi everybody, welcome back again. We'll move on to topic 6.3 now, which is our first type of atmospheric pollution. And you can see from the title, it's the subject of photochemical smog. Also there from the title, you can see we need to discuss two things straight away. Number one is, what is smog? It's actually a very generic term, and smog can be created from a lot of different types of pollutants. And then secondly, we need to look at the idea of the photochemical effect, which in essence is the effect that sunlight can have on the specific pollutants that make up smog in the first place. Before I show you the syllabus as usual, I think it's just worth giving a definition to the term smog. Like I said, it is very general term. So general, in fact, that as you can see from the definition above my head, the word smog comes from two terms: smoke plus fog. Basically, what that means is there's two components of smog. One is gas or gaseous pollutants, and the second one is smoke, which is solid pollutants. Okay, so let's see what the syllabus says. Again, as usual, a lot of writing, but I'll zoom through it fairly quickly. If you want to go through the details, I think it's worth just pausing the video at this point and having a look through the terms. Number one, we need to discuss the pollutants that make up smog in the first place. And as I said, those include gases like carbon monoxide, carbon dioxide, nitrogen oxides and sulfur oxides, but also solid particles, unburnt hydrocarbons, soot and carbon. Secondly, it says in the presence of different pollutants are formed, secondary pollutants. And under that, it says the main secondary pollutant that's formed because of the photochemical effect, the effect of light on these primary pollutants, is ozone. Now, it's very important here, please don't confuse the type of ozone we're talking about here, which exists in the troposphere, which is the bottom layer of the atmosphere that we breathe. Don't confuse it with stratospheric ozone, which we talked about previously as the ozone layer. Stratospheric ozone, or the ozone layer, is useful to us because it absorbs UV light. Tropospheric ozone is a harmful pollutant, which can be deadly, in fact, if it's breathed in the troposphere. It tells us that tropospheric ozone is very reactive, and for that reason it can damage plants, animals. Specifically, it causes lung diseases in humans and damage to the eyes. We need to talk about the severity and the frequency of smog events in terms of local topography, or the lay of the land around cities, climate, population, use of fossil fuels, which release the primary pollutants in the first place. Then we need to talk about thermal inversion. I'll go into that in a little bit of detail, but it's the effect that hot weather has on forming a lid, basically, over certain cities and preventing air from being circulated and therefore exacerbating the pollution problem around big cities. I won't go into detail now, I'll talk about that a little bit later. Because smoke is a component of smog, it's made worse by burning of crops and burning of wood from deforestation. It can cause severe economic losses. That's a statement of fact, especially in terms of the number of person hours lost with people that can't attend work due to respiratory illness. And then finally, as usual when we talk about pollution, we'll talk about pollution management strategies. And again, as you can see above my head, we'll talk about the three things we always talk about in terms of pollution management. One, how can we change human activity? Number two, how can we regulate emission of pollutants in the first place? And then thirdly, and the least desirable, how can we clean up pollution once it's actually in this case, in the atmosphere? Obviously, smog, I'm sure you realise, is a problem in big cities. So we kind of restrict our discussion here to this issue in very big cities and megacities. Which brings me nicely segued into a couple of pictures that I can show you. See if you can recognise these cities before I tell you. Well, number one, This is a pea super London fog. We associate it generally with Sherlock Holmes films, Jack the Ripper films. We kind of associate it with the 1800s, maybe the late 1800s. But pea super, or very thick smog events, continued in London, especially up until the 1950s. The reason it's called pea soup is because this type of smog, as you can just about maybe make out in this picture, was kind of green, had a green tinge. And the reason it was green was because one of the main polluting gases, or the main primary pollutants here, was sulfur oxides. And those sulfur oxides came from heavy burning of coal. So obviously, you know that Britain was the birthplace of the Industrial Revolution, and it built its industry on coal, on using coal as fuel. Not only in industry, steam engines especially, but also for heating people's homes. This picture was actually taken during it was called the 1952 pea super calamity. It sounds funny, but in 1952 there was a 4-day smog, and it was so thick visibility was reduced to about 1 meter for these 4 days, and approximately 1,000 people died over that time due to respiratory problems caused by the fog. You might recognize this. This is downtown LA, downtown Los Angeles. You can see rather than green, this smog is brown. I'll talk about this in a little bit more detail. This is a more typical kind of smog we associate with more modern times. This brown haze is caused by nitrogen oxides, especially nitrogen dioxide, which is ostensibly a byproduct of the combustion engine or the prevalence of cars. This is New Delhi, very, very thick smog here. I read recently, I believe that in 2020, 9 of the worst cities in terms of atmospheric pollution or smog were Indian cities, and this is one of them, the capital of India, Delhi, and this is Beijing, very, very thick, hazy smog there as well. Okay, so that's the basics of what smog is. We need to talk a bit more detail about the components now and how it's formed. So as I said, it's a mixture of gases, gas pollutants, and solid pollutants. The solid pollutants are just basically small particles, and we generally measure those in 2 measurements, PM10 and PM2.5. So it's the average concentration of particles. PM10 refers to particulate matter 10 micron or micrometer diameter, and then obviously PM2.5 relates to small particles of diameter 2.5 microns, which is a millionth of a meter, a micron. Very, very tiny particles, so tiny they get into the lungs and they are responsible on their own for especially lung cancers. However, when they mix with other gaseous pollutants like carbon monoxide, carbon dioxide, sulfur oxides, and nitrogen oxides or nitrous oxides, they form this soup that we refer to as smog. The gases especially come from car engines, but also heavy industry. I showed you a picture of New Delhi before, and 2 big problems in Delhi actually I've read. One is a lot of heavy industry in the city, especially the steel industry. But secondly, it's also surrounded by a lot of farmland, and periodically farmers burn the waste crop, and that smoke also adds to the pollution problem in Delhi. Okay, so let's go through these things in some detail. Volatile organic compounds or volatile organic carbon. These particulate matter that can volatilize or turn into gases very, very easily. So very, very low boiling point compounds. So I've said here, nitrogen oxides and VOCs, when they're acted on by ultraviolet light, they release oxygen atoms. Those oxygen atoms can then join to other compounds. If a free oxygen atom, or a free oxygen radical, we should call it, joins to O2, which is an oxygen molecule, it forms O3, which is ozone. And ozone is a very dangerous compound, especially in terms of lung disease, respiratory disease, especially dangerous for people that already have lung conditions like asthma. Obviously, if there's more UV light, that problem is worse and the more tropospheric ozone is formed. So it's especially associated with very sunny places in the tropics close to the equator, and cities like Mexico City that are at high altitude, where there's less atmosphere to absorb incoming UV radiation. I've said here, as I mentioned before, smog is also made worse by the burning of trees. It adds to the smoke content. But then it's worth noting that places like Mexico City, or places where you've got this high use of car engines, as well as joining to oxygen atoms, these oxygen radicals that are released by UV light also join onto nitrogen oxide and form nitrogen dioxide, NO2. And that's what we generally associate with being photochemical smog. I'll show you a little picture of Mexico City later in another context. But the cities like LA that I showed you before, when you've got this kind of brown haze across the city, we associate that as well with Mexico City. That's nitrogen oxide smog that is formed from this breakdown of ozone. So ozone is less of a problem in Mexico City, but nitrogen oxide smog, photochemical smog, is a big problem. Basically, it's just substituting one dangerous pollutant for another dangerous pollutant. In the 1990s, Mexico is generally thought of, certainly by the United Nations, as the most polluted city on earth. Thousands of people died in Mexico City alone due to respiratory illnesses just caused by smog. There's been a little bit of a success story over recent years because of new legislation to try to bring car use down, cleaner engines, we'll talk about later, and also the extension of public transport in Mexico City. It's certainly not as dangerous to breathe in the air in Mexico City as it once was, although it's still not a very clean environment to live in. Okay, so sorry, as usual, I'm getting sidetracked, but let me move on again. So very quickly, where this tropospheric ozone is formed in high concentrations, we've already mentioned it can cause respiratory problems, damage to human eyes and other animals, of course, skin irritation, breathing problems. Very dangerous for people who already suffer from asthma. And it causes damage to man-made fibres as well. Not just clothing, but other textiles and other types of fibres that we use all around us, plastics as well. Like I said, in some cities it's less of a problem because it associates with nitrogen oxides to form nitrogen dioxide. So photochemical smog is this soup of ozone, nitrogen oxides, VOCs that kind of exist in this uneasy equilibrium. In some places the problems are much worse than others. In places where there's less wind for various reasons to sweep this smog away, it can make it worse. Mexico City is surrounded by extinct volcanoes and mountains, so there's usually very little wind across the city to sweep these things away. And therefore we associate it two different types of smog. Summer smog occurs when there's a lot of light, a lot of heat and light that forms ozone in the first place. And then winter smog occurs when there's a thermal inversion, which I'll try and go into a little bit of detail. Thermal inversion occurs when basically different layers of air exist above a city, and therefore the air that's close to the ground can't mix with higher air. So it kind of puts a lid across the city. I might be able to make that a bit clearer with this little graphic. This is a picture of Mexico City. You can actually see the photochemical smog, brown because of the large concentration of nitrogen oxide. And in winter in Mexico City, although it's hot, well, very hot in the afternoon certainly, it heats up the ground. the ground heats up the atmosphere and the hot air rises. As it rises, it's replaced by colder air. And we have this situation then where cold air is circulating above the city, warm air is circulating at high altitudes, and cold air is circulating near the ground. And then there's a kind of line between these two air bodies, which is called a thermocline. And because of the two different densities, this cooler air can't mix, and that's when the pollution problems become very, very severe in the city. I think I said it was in winter. I did mean summer, actually. The thermal inversion occurs during the summer, when the ground becomes very, very hot. The hot air rises, and then it can't. It's replaced by cold air, and the cold air can't mix with air above it. So in Mexico City, in the summer, when you get up early, like I used to have to do to go to work, you find it's very, very, very cold in the morning. And the reason for that is this cold air coming down towards the surface. Okay, I'm not sure I did a great job of explaining that, but the basis is that we end up with this air mass above the city that can't mix, and therefore the pollution becomes very, very dense in the summer. Okay, and then the final slide I want to cover today, as I promised, management strategies to deal with smog. Well, the three things we talked about before. Number one, you can alter human activity. These are things that I came up with myself, but I'm sure you can add to this. Number one, less use of private vehicles and very polluting trucks. The introduction of more efficient engines. Encouraging people to carpool, use less cars if possible. Get people into public transport, I guess. Regulating and reducing emissions. Well, making sure that cars are fitted with technology that reduces some pollutants like sulfur oxides, like catalytic converters, which fit onto the exhaust. You could extend this to industry where you fit scrubbers onto chimneys which take gases, again, like sulfur oxides, out of the pollution that's being put out into the atmosphere. Changes to make petrol certainly less polluting and more efficient fuels. One thing that could be considered by governments is to switch from road to rail haulage. That certainly produces less of these gases produced per tonne of cargo transported. And then clean-up measures, I struggled a little bit about for this one, but you could consider taking areas, reforesting them, or regreening in city areas. Basically replacing concrete areas with planted areas to try to take some of these pollutants out of the atmosphere. Okay, so that concludes my little talk on 6.3, photochemical smog. I hope that was reasonably intelligible, easy to follow. Obviously, we'll talk a bit more in the classroom about it. Take care, everybody, and I will speak to you in the class.